Welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever. Good. So I think we will... What will we do? Let's do a fetch and prune all remotes. Then I think we can... Oh boy. Okay. So we pull here and we will delete this one. And this one. Okay. What about this one here? I think this one is already merged, right? Yeah, I think we can delete that as well. Now, regarding this branch here, there was one more thing that I wanted to look at in W. Yeah. W3D view. We have the get terrain. No, get ground height here. Get height here. This one. Height around position. So here, initial ground. Right, so here in the previous session we did change this one here from terrain height, get height to this one, which does apply the smoothing. But here we should probably use the old one. So you do a const ground level. So what this is a real, yeah, const real ground level. So let's call this like accurate ground level. So there will be the terrain logic, get height, ground height. There we take also these positions here. And then we take this guy. There we go. And And the initial ground level will be this, yeah. And I think this way we will preserve like the proper ground level, the initial ground level for the scripted camera, the way it was in the original game. Yeah. Maybe we should call this initial ground level. Maybe call this height of ground. Height of ground at the time of at the begin. Height of ground at the begin. Height of ground at the begin. Height of ground at the initial position, the first position in the beginning of the map. First position of the map. Only used to maybe we give a bit of context here. So it's the initial ground level. Ground level for retail, for preserving the original look of the scripted camera. Because it does affect the positioning in subtle ways. It does affect the positioning in subtle ways if the ground level is changed. Because alterations do affect the positioning in subtle ways. Alterations to the ground level do affect the positioning in subtle ways. Okay, then we can remove this as well. Okay, I think that will work. Yeah. Maybe we can run the oh. Maybe we can run the one of the cutscenes. I think it was a GLA Mission 2 intro where this was pretty obvious. So I go to load game, and then I think it's GLA 2. The Prince Kassad mission. This one. So far so good. Okay, it's hard to tell like if this was now 100% correct, but I didn't see any obvious mistakes. So I think for now we can be happy with it. Okay. Okay. Cool. Then we can merge this down. Okay, great. Then with this done, let's get to GitHub and let's look at let's take a look if we need to attend to any of our own changes. Let me see here. Part of the public contract. Okay, what is this here? It's hard to read. So, let's see if we can put this here. All right. Turn a state machine transition methods. And the next state. So, haha. So this one is only called internally, huh? The next state. I think the idea for it being public was that maybe then you can skip it from outside. Yeah, it could be internal updates. Okay, for some reason we cannot find references to enter next state. Okay, then let's move it private. Fair enough. Enter next state. Which commit does this need to go to? Here. Okay, we first need to do a rebase and fix the merge conflicts. Which we have here. Virtual void draw. Is this an override or not? I don't think so. Or is it subsystem interface? Oh, it is. Draw. Okay. Then we need to take the blue one. And then we add a draw overrides. Okay. Okay, so far so good. And then we do a squash. Which went without error somehow. Fair enough. then I think this one should be fine. Push. Okay. Fixed. Looks a bit difficult to read. Also, makes it look a bit like hackware. Rebased. Makes it look hackware. Okay, so this one is resolved. Okay. 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 Good. Then this one is good. Here, what do we have here? Yeah, so I think this one is also fine. It's testing, and this one needs review. Yeah, I was thinking that maybe we can split off some of the changes from this one here and then close this pull here. So let me take a look at what is useful in here. Oh boy. So isn't Venus. Right. Okay, what do we do with this one? I would say we first... Well, we can't really rebase it, right? Because there will be conflicts. We can maybe do set text. Swatches count 0. Fix clamping. Oh, that didn't really fix anything, right? Huh. Clamp coordinates. Right. Mm-hmm. Min-max, okay. Why does it say fix clamping here? Well, why is that? Fix clamping. It's not really fixing it, it's just rewriting it, right? Yeah. Okay, how about we just reapply those fixes? So let's go to main branch. Yeah. So let's take a look. So render. There we go. Let's go in there. Smudge. Render. There we go. So we are looking for this thing, yeah? There we go. So I think the way to write it is this clamp and then smudge offset x equals that and smudge offset y. There we go. I think that's it, right? X, Y. There we go. Clamp. Okay, so it's basically just rewritten now. Yeah. Y, 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 X, X, X. It's just a refactor. Yeah. Okay, so this should be fine. Then let's see what else we have. So the static assert looks useful, yeah. Then we can remove this, yeah. Okay, great. Okay, and then smudge's batch count. Mm-hmm. 0. Batch count 0. Then here we have flush smudges. Flush smudges. We don't need this one anymore. No, this one is not needed. Remove that again. But this is needed, right? Flush smudges, and then remove that down here. Yeah. Or not. Excess. Vertex buffer. Maybe it should jump here and set the vertex buffer here. Look. I think that makes sense. Okay, let's go with that. So then we have here something. Okay. Fixed static is set. Okay. Okay, then we have that. What else? UV value assignments. Right, so this one is very unholy to read here. So let me fix that. Okay. And what else do we have? Yeah. Bytes per pixel. Okay, maybe this one can be a separate change. Mm-hmm. Mm-hmm. X 0, 0. Oh. Clamp coordinates. So, aha, that's interesting. So it says even if this one is larger than text clamp, then this also goes to 0. Why is that? Why is that happening? Huh. Clamp coordinates. Huh. Okay. Let's test that. See if it still works. Mm-hmm. Mm-hmm. Okay, we have compile error. Ugh. Ah, that doesn't work. Uh-huh. Interesting. So is it legal? Let me ask. Is there anything we need to? Is there anything we need to pay attention to in regards to? I think we need to pay attention to in regards to C++, Go2, and RAII. In regards to Go2 outside. Go2. To say jumping out of scopes with C++ Go2 and R. Few very important things to understand when mixing Go2. It's mostly safe to jump out of a scope, but dangerous or illegal to jump into one. So here we have a resource. Goes out of scope when jumping to clean up. Its destructor is called jumping into a scope. Go to inside. Constructor not run. Right. Mm-hmm. Okay, so this will work. Okay. Okay, then this looks like we are safe and we can put that here. Mm-hmm. Okay, cool. Good, then let's test that. Mm-hmm. So we are looking at a microwave tank. Yeah. Mm-hmm. 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 Okay. So we need to get some microwave tanks. Oof. Okay, well, that actually looks very wrong. Okay, interesting. Interesting. It looks very funky. Wow, okay. I wonder if that's related to the clamping. Yeah. Mm-hmm. Interesting. Mm-hmm. Okay, so one of the changes we did wasn't so good. I suspect it's a clamping change here. Mm-hmm. Mm-hmm. Clamp coordinates. Huh. Interesting. So let's put it back to what it was before. Mm-hmm. then it's not really clamping, right? Or is it? Because it sets it to 0. It's not clamping it at this max value. Okay, that fixes it. Okay, that's interesting. Yeah, then interesting. Okay, well then this one has to stay. I think what we can do is let me ask the following code. It is not really clamping. It's not really clamping. It is setting the value to 0. Always setting 0 if out of bounds. What is a better terminology for this? Not clamping. Clamping. 0 invalid coordinates. Invalidate out of range values. I think that's fair. 0 coordinates set for referencing text cells outside the view. Text cells outside the view. So I would say what we do then is we consolidate these and put them together like so. Let's say if this is smaller than this or that. Okay. I think that's better. Okay. Okay, let's test that again. To make sure we're not breaking anything here. Yeah. Okay, cool. That looks fine. Cool. Okay. Then they take the cliff? They can. Look at that. Shoot up in the air. Oh, they can't attack here. Ah, they can. Shooting up there. Interesting. Huh. So when you pause the game, then this effect still keeps on going. Okay. Maybe this is also something we can fix. Okay, but I'm happy with this change. Then I think we can make a branch for this. So there will be fix microwave tank code. Or let's say smudge code. Okay. Let me say fix smudge, fix and improve smudge code. So W3D smudge. Say minor fixes. Fix minor errors. Okay. Good. Let's make a pull for that. Then this is split. Oh boy. Split of that. This change does a few, adds a few minor fixes to W3D smudge, a few minor fixes and refactors, a few minor fixes to smudge. The static assert turns the comment to an actual, to a compile guarantee, to the smudge offset y is now used correctly. But visually appears to change nothing. Visually appears to change nothing. To have no notable, no obvious impacts. Three. The go-to in that now jumps out of the, say, the VB access buffer in this is now no longer accessed. It's now no longer set vertex buffer. What does this do? No longer forwarded before the lock is lifted. What else do we do? I think that's good enough. Say fix rendering minor gen ZH. Okay, so we have that. Then let me take a look at take a look at the pausing of this effect. So I think it's not even it's not even it's not decoupled from rendering, right? Like it needs to be it needs to be scaled by the logic rates. How do we do that? Smudge render. Poof. How do we do that? Yeah, how do we prevent it from updating? There's just a render function. There's no update function. Let me see the smudge manager. There's add smudge. Where's this called? Aha. Aha. Okay, I think we need to first do a bit of debugging on this. So Let's build some one. Let me put a breakpoint in here right now. It is being called, and it does add a smudge set. Huh. Huh. It does it every frame. Huh. Okay, that's impressive. Okay. Yeah, so it looks like it looks a bit uncanny, doesn't it? Yeah. What I think what looks weird is on this effect that like you can see that these are different pieces. I think they need to it's too easy to see that these are different like small pieces. So it looks weird in a way. Yeah. It looks okay in the center because there are probably more on the spots. But here outside it looks really weird. Right. Okay, so anyway. So what we can see is that this effect is totally bound to render updates, which is wrong. And maybe part of it is that it adds a smudge set in here. Head set. Remove from free list. Add to used list. Okay. Set. Smudge to set. Temporary hack that checks if texture name starts with smud. Of course, it's a temporary hack. Yeah, temporary for a couple decades. Yeah. Mm-hmm. Mm-hmm. Visible smudge count. Oh. Mm-hmm. Mm-hmm. Particle system manager. Update. So this update, this is a logic update. Yeah, last logic frame. Okay. So here we have a logical update. Smudge. This is the smudge count. Render. Render. Okay. Reset. Set smudge count last frame. What is that? Reset. Clear all the smudges after rendering. So I think we need to move it. Let me do a close other tabs. So we have a particle system manager where we have an update function. Particle system. We want to go to the particle system manager update place. Here. That's the one. Okay. Yeah. So let me move over the code from do particles. So let's say we take this guy and we put that here, and then we take these guys here, and then we take, well, all of this here. Set up all per particle. Smudge to set. Yeah, so I think we are interested in this one here. So let's put that here. And then we also need reset. So the reset we will have to do. Set smudge count last frame. What is this one used for? Smudge count last frame. Is this just a diagnostic? Seems it's just a diagnostic, which is not even used. So to me, it looks like we could just remove it. Yeah. We probably do need the resets. So the smudge manager. Smudge manager. So we have game client and then smudge, right? S. Smudge, okay. Then let's go down here. So we do a reset. Yeah. Then only look at particle point style systems. The other stuff in here. So all of this down here, this is not smudge related, or is it? Or per particle. Field particle count. What does that mean? Well, this is smudge related. This is not set up all the per particle. Get all particle systems. Yeah. No, I think this is fine. So we take this guy, okay, blah, blah, client random value. Yeah. Okay. Huh. So it's using smudge. I think what we can do is we say if the smudge manager, then we do all of this here. Yeah? Then this one we can also move up here. So, and then now this won't be possible here. So let's comment this here out for now. We don't care for that. What about this here? Aha. Aha. Okay, we can't. Maybe we can't move it to this update now. Okay, maybe. So the problem is that here we set like random offsets for every smudge that we place in each new render frame. And so like they would just jump positions. And we can't have that. How do we decouple this? It's a bit of a problem. Huh. Yeah. That's a problem. Can we tell it? I think it makes sense that it's part of the render update, but we need to control something on the logic side. Or at least, well, at least tell it that to not jump it every so often. Yeah. It's much to set. How do we do this? Yeah. Right now, I don't understand how we can do this. No. We do a per render frame. This will be adding new smudges at random locations. How do we tell it to stop doing that? We need a... Yeah. Need a... Okay. So when we scroll around over the map, then we will see different... It will show different units depending on where the camera is. And then if we scroll onto microwave tanks, then we want to see the smudge. If we scroll away, then obviously it wouldn't need to go through all this trouble anymore. Yeah. So in that way, this is all good. Now, if we did it on a logic side, then it would always create those smudges. Yeah. Well. Yeah. I think what we need to do is we need to have another. Aha. I think what we need to have is this one is controlled on logic side. Yeah. But then here in this update, in the render update, we need to set a flag here, whether it's visible or not. And only if it's visible, it will actually process this and render it later. Aha. So how about we do the following? In the smudge set, add smudge to set. Smudge. Yeah. Smudge. Set. But now then we need an association of this particle. Okay, I have a rough idea of what we need to do. So basically we do add the smudges in here on every logic tick, so to say. Clear the smudges after rendering since we fill again each frame. Okay. This comment is not relevant here. Remove that. Okay. So set. Now we can remove this condition here. We can put this together. Okay. Particular list. Okay. System manager. So here. What is this returning? Particle system list. So I think here we can simplify that to that. Okay. Sys, okay. Particle system list again. Update. I would say we move this below that. Okay, then we don't have the culling here. We have a position, we have a piece size. I think we can just put that here. We have a pause, we have a smudge. Okay. Okay, so I think that looks good. Now the problem is, how do we associate the particle with the smudge thingy? That's smudge set. Smudge set. Smudge set. Smudge. Add smudge to set. I think we would have to give it smudge to set. Smudge to set. Head, free smudge, head. Remove. Add tail. What is this? Oh boy. Yeah, so the problem I have right now is, how do we, once we have added the smudge here in the logic update, how do we then associate this particle with this smudge that we have added in the render update? That's not obvious. Yeah. Yeah. Well, we would probably need a hash map. Yeah. So we probably have in here a std hash map. Then I don't know, we put a humans. Let's put a void as void pointer as key. Void pointer. And then no, it would be inside here. Why do we have multiple sets? Add smudge set. Can we have more than one at any time? Global smudge set. Huh. Do we have more than one or just one? Let's assume we just have this one, yeah? Yeah. unsigned in 64, yeah. Or size T. Or yeah, size T maybe. So this one will allocate smudges, right? Yeah, okay. So these will have stable pointers. Add smudge set. We don't have a way to get a smudge set. Huh. Smudge set. Hmm. Maybe we do a void just a smudge set. That's also bad. Ugh. So let's do find smudge. Let's do here add smudge to set size T identifier. Yeah. Then we need here a std hash size T smudge. Used smudge map. Okay. Now this one is now complaining for some reason. Why? City hash map, sorry. So used smudge map. Now on reset we will reset. We will do a smudge map dot clear, right? Okay, and then here when we add a smudge set, we have a size T identifier. And then here we do smudge map dot identifier equals smudge, right? Okay. So we stored also in the map. Yeah. Okay, when we have remove smudge from set, then we also need my smudge. Then in the smudge, we need to have, how big is this? 144 bytes. Jesus Christ. 16. Why is this so big? 12, 8. Uh-huh. Interesting. Uh-huh. Let's do here size t identifier. Okay, so when we create this smudge, then we create it here, smudge. Then here we will have smudge identifier equals identifier. Okay. Okay, so this looks okay. Remove. Okay, add today. Blah 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 blah. Return smudge. Okay. Now I see that this is very stupid here. I think we can simplify this and say if smudge remove else we do this much, and then we can remove all of this here. All right. So create new one, create new. Okay. Don't change too much. Create new smudge. Allocates new. Well, it's very obvious what it does. No need to comment. Okay, so this is okay. Head okay. Blah blah blah. Okay. And here we also need to remove it. Smudge map dot erase my smudge dot m identifier. Okay. Okay, great. This works. And then now add smudge set. We have that. Okay. Good. And then we need a function here. Find smudge size t identifier. No? And that will return a smudge. And yeah, it's const. So why do we have red in here? What is this? Why is this red? Ah, right. That's why. So and now we go through all the lists, right? Used. How do we iterate this thing? I think like this. Well, that is not. No. There we have a const problem. Okay, then this needs to be not const. Okay. Head, and then while this, and then we say if find smudge. I think we have to put the same here. Remove get smudge. Then you have find smudge identifier. We add a new function here as well. And then here we just do return map.find identifier. Well, that will give us an iterator. So we do hash map. Let's do a type def hash smudge smudge identifier to PTR map. Okay, and then here we do this iterator. Can we have a const iterator? Then we say if it is not, it's not the end. Then we return it second. Otherwise, we return null PTR. And then we can say here if smudge smudge equals head. Let's call this smudge set instead. Smudge set. Find smudge. Is this one a pointer? What is this? Head gives us a pointer. Find smudge. Then if this, then to find smudge. Identifier. And if that's the case, then return smudge. Otherwise, return null PTR. No? Okay. Okay. I think this looks fine. So now we should be able to store the smudges with an identifier, which we will use a pointer for. And then that should work. What do we have here? Undefined. It's probably just IntelliSense being stupid. Okay. So I think this is looking fine. Good. So we add a set. And then we have here add smudge to set. And there we give now the P. We do a static cast size T P. We can't do a static cast. We need to do a reinterpret cast. Size T. Size T is probably not the correct type for this, isn't it? Maybe we just pass as a void PTR, make an identifier the void PTR. Yeah. Maybe we just make it a void star identifier. Can we do that? So identifier is void, okay. Identifier. Okay. Identifier is still that, okay. Okay, so that should work, and now we can just pass P as our identifier. So the particle pointer becomes the identifier for the smudge. Okay, that works. And then get hardware support. Smudge manager. W3D smudge. Test hardware support. I think we need to make it a virtual function. So we make a virtual bool override. Yeah. Can make it also final. Okay. So this currently overrides nothing. So we need to go here and add a the pure virtual maybe. Okay, then so we have that guy. Can we make this private? Maybe. Then we have to move it on here. Let's move this up here. So test hardware support, okay, blah blah. So test hardware support override, okay. Then we should now be able to say here Smudge Manager hardware support, right? Okay, then we can also remove this one here and that, okay. Okay. It's using Smudge, okay. Okay, so this looks promising. Then next we would need to add another flag to the smudge and say here, so we have opacity. We can probably say alpha of center vertex corners. That's 0. Center vertex. Yeah, opacity. So opacity is so memory layouts, opacity, offset, blah blah, identifier. Yeah. So I think what we can do is we add a boolean here and say draw whether the smudge needs to be drawn. Draw. Okay. Okay, then inside particle updates, now inside this particle updates, we then need to say so first we remove this. We remove the reset. We remove all of this here. And then we have smudge. Then we remove this here. This. And then we also remove this. Okay, and then in here we say if we need a set. Hold on. No, we don't need a set. We do if smudge equals smudge manager find smudge, right? And the identifier we use a particle. There we go. And so if we find one, then we now say smudge draw true. Yeah. Well, we still need to say draw true. I think we need a in smudge we need a reset void reset render. Reset draw. How about that? Reset draw. And then here we do smudge head. Why is this called head? Head. Use smudge list. Mdraw equals. Let's just say false. Okay, reset draw. Great. Okay. Then here, let's type true. And then, so at the beginning here, we need to say if the smudge manager, then the smudge manager reset draw, right? Well, that didn't work. That's smudge manager. Right, so we need a reset draw here as well. Let's put it down here. Reset draw. So we have a reset here, and then we do a let's call this smudge set. Let's also go ahead and call this smudge here. Smudge. So it's a smudge set. Now we do a smudge set. Reset draw. Great. Okay, that looks great. Here we have a problem. Smudge set, abstract class, pure virtual functions. Smudge set, test hardware support. Oh. That's the wrong function, isn't it? Wrong class, I mean. needs to go here. Mm-hmm. Good, then we have that, and then we need a what else do we need? Reset draw. Reset draw, okay. Yeah, I think that's it. And then here we can now call reset draw, which will reset it. And then every time it will go in here and check if it can actually draw it. Yeah. Okay. Now, support, okay. I think it's fine, yeah. Smudge, okay. Draw, okay. Okay. Yeah. So to me, it looks like this could work. Let's see if it compiles. Yeah. So basically now in the logic update, we do the, we add those smudges every frame. And then on the render update, we only check if they should be drawn, if they are in the view here. And if they are, then, hold on, we're still missing something. In W3D Smudge, we need to, here, why smudge? Why smudge? So we want to say here smudge get used smudge list head. Used smudge list head. Smudge list head. Sorry. So I think here we simply need to say if smudge mdraw, if not mdraw, then continue, right? Yeah. Okay, I think this might work now. It does compile. Yeah. Okay, let's see. Oh, it's hanging. Huh. Smudge is 0. Right, it's not advancing. I see. How do we advance? Smudge set. Successor, right? There we go. Then we need to write this a bit differently here. We need to say for smudge equals head. Like so, right? Okay. Smudge set equals that. Smudge set is not PTR and that. Okay. Okay. Did we add anything else there that is looping? Smudge. Here. Here as well. Okay, and then equals smudge set dot 6. Yeah, okay. Okay, was there anything else? Smudge map clear. Smudge map clear, smudge set. Yeah. Here we can remove this plus, I think. Okay, I think that's that should fix a problem. Okay, so that is running. Then let's build some tanks. Okay, that looks promising. Yeah. So let's take a look at it. It still looks very fast though, doesn't it? Yeah. It still speeds up, doesn't it? Okay, but that's because... Yeah, okay, no, that works correctly. Yeah, that works. Fantastic. So now the microwave effect is actually bound to the logic update. Okay, cool. That's great. So now, no matter how fast the render FPS is, this one should always have consistent visuals. No. Okay, cool. So if we now pause the game, then the effect will also pause. Yeah. Okay. I think we can also do a Shift P. Yeah. Okay, cool. Now we can actually pause the effect. Cool. Oh, we have a hang when we go outside. Oops. What is this? Aha. Right. Ah, I see. How about we do a for Smudge is not PTR and this. Can also just do like that. Okay. Then we can remove this here. Okay. Maybe we can do the same in here where we don't write this here. Yeah. Smudge. To make it easier to read, we can also take this out here. So that the line is not so long. Okay, cool. Then let's test that again. I'm very happy that this worked nicely. Okay. Okay, great. Then let's build some tanks here. Okay, that's this. Ah, shit. Uncapped. So good. And so now we go out, then everything works. Yeah. Okay, cool. Okay, cool. I like that. Something looks uncanny about this effect, right? Yeah. It needs to be smoother. Like, let's slow this down. these smudges, they are too sharp. Like they need to be smoother on the edges, right? Let's pause this. Like, to me, it looks like they need to be larger and like smoother. Like you can see that these are like small pieces, right? So it looks weird. Like if they, especially when they're here on the outside, right? Like this, like you can see that, like it's like a piece, an isolated piece. So I think they need to be larger so that they have smoother gradients. Yeah. Also, look how far they reach. Oh. Ah. Ah, okay. That's an issue. I see. It saves positions relative to the screen and not relative to the unit. Oh, I see. Well, that's a problem. Uh-huh. Okay, there's still work to do here. I see. Uh-huh. Uh-huh. How can we fix that? Maybe some of the positioning stuff. Let me see. Offset. Draw. Here, position of the smudge center. Maybe this guy needs to actually go. Aha, this one probably needs to be updated here in the render update. I suspect. Let me see. Particle sys, position, pos, particle get position. Huh. So what does this return here? Mpos. Mpos. Get position. Pos. Huh. Okay, that I don't understand how that works. Get size. P get size. P. Huh. Set. Get alpha. So what if we still update position, size, and opacity in here? Will that solve the issue or not? So let me see. So we put him here and then we pause. Yeah, okay, so the artifact is still here. So you see that the smudge is here. Aha. Aha. Well, that's not right. And if we don't have it paused, it still happens, yeah. Okay. Okay, so this is something we need to solve still. Right now I don't know why this happens, but it looks like this one doesn't fix it. It's probably hard to see in the video, but the smudge, like if you look here, the smudge is there. Oh, if we zoom, then the smudge is gone. Now it's back. Yeah. Yeah. Get the view space center. Okay, so we will need to study how this positioning works. I would expect that when we scroll around, that the position. Yeah, we need to understand this. Yeah, I don't understand it right now. There's probably something in here. Yeah, good. Then I think I will take a break here. It has been, 2 hours 40 minutes. Good. Then it's here. I wish you a great day or night. Until next time. Goodbye.